Hey YouTubers, thanks for joining me here in another video with random chemistry. In this video, I want to talk about balancing chemical equations that contain polyatomic ions. Alright, let's balance this chemical equation. We'll start out by drawing our line. And then next we take account for every element in this equation. Now this equation looks intimidating. There's a lot of different elements and they're spread out everywhere. What's great about polyatomic ions is that we can treat them as if they were one element, as long as it's on both sides of the equation. So we have NH4, NH4, PO4, PO4, NO3, NO3. So because these polyatomic ions are on both sides of the equation, we can treat them as one instead of breaking up the elements. So NH4, and we have 3 of them because it's in parentheses with a subscript of 3. PO4, we have 1. PB, 1. And NO3 has a subscript of 4, so we have 4. So on this side, let's keep them in the same order. NH4, PO4, PB, NO3. Alright, so NH4, 1, PO4 has a subscript of 4, PB, there's a subscript of 3, and NO3, just 1. Okay, so right now, none of these elements are balanced. So it can be tricky to know where to even get started. What's awesome about balancing chemical equations is that if you get your math right, you can get through this with trial and error. So let's just get started. I'm going to start with my phosphate, my PO4. So on this side I have 1, and on this side I have 4. So to get from 1 to 4, I need a coefficient of 4. And remember that changes everything in my formula. So now 4 times 3, I have 12 NH4. And then I have 4 times 1 is 4. So my PO4 is balanced. Let's go ahead and work on my NH4. There's 12 on this side, and I only have 1 on this side. So to get to 12, I need a coefficient of 12. So that brings me to 12, but that also changes my NO3. So 12 times 1 is also 12. So now let's balance NO3. We have 4 on this side and 12 on this side. To go from 4 to 12, we need a coefficient of 3. So we'll put a 3 here. So 3 times 4 is 12. So now that's balanced, but let's not forget to multiply the PB. So 3 times 1 is 3. Oh, and it worked itself out. So we've got 12, 4, 3, 12. All right, now let's double check our equation. 4 times 3, 12. 4 times 1, 4. 3 times 1 is 3. 3 times 4 is 12. We have only 3. PO4, we have 4. 12 times 1 is 12. 12 times 1 is 12. This equation is now balanced. Alright, so here's our second chemical equation, and it also has a polyatomic ion. But if you look, this polyatomic ion is not on both sides. We'll draw our line. Because this polyatomic is not on both sides, we can't treat it as if it was its own element. We have to break it up into the single elements within that polyatomic ion. So we'll account for magnesium, oxygen, hydrogen, hydrogen again, and then chloride. And let's keep them in the same order on the opposite side. And let's take count. Magnesium has 1. This polyatomic ion has a subscript of 2, so that means there's 2 oxygen. And there's 2 hydrogen, but there's another one here, so that's 3. And there's 1 chloride. On the right side, magnesium has 1, oxygen has 1, hydrogen has 2, and chloride has 2. Okay, so let's look at this chemical equation. Let's start by balancing our max balance, so let's go to our oxygen. So to get from 1 to 2, I'm going to place a coefficient of 2. So that's going to change my oxygen. 2 times 1 is 2. And it also changes my hydrogen. So 2 times 2 is now 4. Okay. Now we come to the side to balance hydrogen. So we've got 3 and we need 4. But if you look, we have 2 and 1. And what I can do is I can put a coefficient of 2 here. So that's going to give me 2 times 1 is 2, plus the additional 2 I have here, so now I have 4. So that balances my hydrogen, and I have to remember to multiply the coefficient by everything in the formula, so 2 times 1 is now 2. So now my chloride is 2, and it happens to balance. So we have 1, 2, 4, and 2. So let's double check our equation. Magnesium has 1, oxygen has 2, hydrogen, there's 2 here and there's 2 here, so that's 4, and then 2 times 1 is 2. And magnesium has 1, chloride has 2, hydrogen has 2 times 2, which is 4, and then 2 times 1 oxygen is 2. This chemical equation is now balanced. Alright, here's our third equation with polyatomic ions. Let's draw our line and account for our atoms. Fe has 1, hydrogen has 2, and SO4 has 1. And we'll keep them in the same order. Two, hydrogen has 2, SO4 has 3. Okay, and now we have to decide what we want to balance first. So we have our Fe's and our SO4s. Our hydrogens are balanced. So when trying to decide which one to balance first, whether Fe or SO4, take a look at your equation. If you look on this side, Fe is by itself. When you find that the element is by itself and not involved in a formula, it's best to save this for last. So we're going to do our SO4. So to get from 1 to 3, we need a coefficient of 3. So 3 times 1 would be 3. And this changes our hydrogen. So 3 times 2 is 6. So now let's balance our hydrogen on the opposite side. We have 2 over here. To get from 2 to 6, we need a 3. Coefficient of 3 times 2 is 6. And then now we can balance our Fe. So we would put a coefficient of 2 to go from 1 to 2. So now we have 2, 6, and 3. So now let's double check. 2 times 1 is 2, 3 times 2 is 6, 3 times 1 is 3. We have 2 on this side, 3 on this side, 3 times 2 is 6. This equation is now balanced. Alright YouTubers, thank you so much for joining me during this video with random chemistry. Please comment, like, subscribe. I really want to hear from you. If there's any material that you specifically want me to cover, if you have any questions, please leave me a comment. Thank you again for joining me, and we'll see you next time on Random Chemistry.